Welcome to my channel Chemistry Class. Welcome back to Chemistry Class, my dear student. I hope you're doing well. So, in the previous lecture, we discussed the classification of organic compounds on the basis of origin. But today, we are going to study classifications of organic compounds on the basis of structure. My dear student, these classifications tell us how carbon atoms are arranged inside an organic molecules, whether it forms straight chain or ring form or any other atom as present. So let's understand this classification and details. Let's start. Classifications of organic compounds on the basis of structure. Organic compounds are classified into three broad categories on the basis of structure. First one, acyclic or open chain compounds. And third one, first one is cyclic or open chain compounds. Second one, cyclic or closed chain compounds. Third one, heterocyclic compounds. So let's understand them each one and details. The first one, acyclic or open chain compounds. Definition: acyclic compounds are those organic compounds in which carbon atoms are arranged in open chains, either straight or branched, but not forming any ring. They are also called aliphatic compounds. Explanation: carbon atoms link together end to end. These chains may be straight, no branching, branched side chains present. These compounds show simple chemical properties and include most simple hydrocarbon. Examples: straight chain CH3, single bond CH2, single bond CH3, propane. Branched chain CH3, single bond CH, also bonded to C3, is a branched single bond CH3, which is isobutane. Key characteristics of acyclic compounds. First one, no ring structure. Second one may be straight or branched. Third one usually show addition, substitution, or elimination reactions. Fourth one include alkanes, alkynes, alcohols, aldehydes, ketones, etc. Second one, cyclic or closed chain compounds. Definition: cyclic compounds are those organic compounds in which carbon atoms are joined to form a ring or a closed chain. Explanations: the ends of carbon chains connect to form a loop or ring. These rings may be made entirely of carbon, homocyclic, made of carbon plus another atom, heterocyclic. Cyclic compounds are further divided into first one, A, homocyclic or carbocyclic compounds, and B, heterocyclic compounds. Now the first one, homocyclic or carbocyclic compounds. These are cyclic compounds containing only carbon atoms in their ring. There are two types of homocyclic compounds. First one, alicyclic compounds. Second one, aromatic compounds. First one, alicyclic compounds. Definitions: cyclic compounds that have carbon atoms in a ring but behave like aliphatic compounds. Explanation: the ring is formed only by carbon atoms. They are not aromatic because they do not have delocalized electrons like benzene. Their reactions are mostly similar to alkanes and alkenes. Examples: cyclopropanes, C3H6, cyclobutane, C4H8, cyclopentane, C5H10, cyclohexane, C6H12. Characteristics of alicyclic compounds. First one, ring of carbon atoms. Second one, show aliphatic characters. Third one, stable but less stable than aromatic compounds. Fourth one, used in pharmaceuticals and polymers. Second one, aromatic compounds. Definition: aromatic compounds are homocyclic compounds containing one or more benzene rings and show special aromatic stability. Explanation: benzene has 6 carbon atoms forming a ring. Electrons are delocalized, creating extra stability. These compounds have strong odor aroma, therefore called aromatic. Examples: benzene C6H6, toluene C7H8, naphthalene C10H8, anthracene C14H10. Characteristics of aromatic compounds. First one, highly stable structure. Second one, undergoes substitution reactions. Third one, strong smell. Fourth one, found in dyes, perfumes, plastics, medicines. And B, heterocyclic compounds. Definition: cyclic organic compounds in which the ring contains carbon atoms and at least one heteroatoms mean are nitrogen, oxygen, or sulfur. Explanation: when a ring contains atoms other than carbon such as nitrogen or oxygen, it becomes a heterocyclic compounds. These are extremely important in biological system. Examples: pyridine ring contain nitrogen, fluorine ring contain oxygens, thiophene ring contain sulfur. Characteristics of heterocyclic compounds. First one, contains a heteroatom in nitrogen, oxygen, sulfur. Second one, present in vitamins, DNA, RNA, and medicine. Third one, more reactive due to electronegative heteroatoms. Fourth one, used in drugs and agrochemicals. Thank you for listening.